Finalists to the 2020 Engineering Research Project of the Year Award finalist presentations. This is a brand new award that we created this year to really capture those who are doing engineering research on the cutting edge with post-secondary institutions as well as companies that may not necessarily be in the mature market adaptation stage yet. So just a few housekeeping items. Please mute your mics and turn off your webcam during others' presentation. The recording is in process, but I understand that one of the projects we have noted that there shouldn't be any recording due to confidentiality, so we will be pausing it during that time. This recording, if shared, will only be shared with the participants of this finalist presentation and the volunteers who are in this conversation right now. Make sure that you please do not send Zoom messages to all, that's for everyone, or to the judges, even though the function is there, because we will be using that platform to communicate amongst ourselves. You can private message to other finalists when they're not doing their presentations, or to our volunteers if you have questions. So before we begin the other introductions, we would like to begin by acknowledging the indigenous peoples of all of the lands that we are on today. While we meet today on a virtual platform, we would like to take a moment to acknowledge the importance of the lands which we each call home. We do this to reaffirm our commitment and responsibility in improving relationships between nations and improving our own understanding of local indigenous peoples and their cultures. In York region, we acknowledge the ancestral and ceded territory of all the Haudenosaunee, Anishinaabe, Mississauga the Credit First Nation, and Mississauga people that call this land home. Please join me in a moment of reflection to acknowledge the harms and mistakes of the past, and to consider how we are and can each, in our own way, try to move forward in a spirit of reconciliation and collaboration. So about the award, the Engineering Research Project of the Year Award aims to recognize projects by licensed professional engineers and their contributions to the community. It raises awareness of the engineering profession, connects companies and post-secondary institutions to the local engineering community of potential community partners. And we're excited to announce that for the Engineering Research Project of the Year award, we will be awarding first to third place this year. And that will be presented in a public virtual awards ceremony, also on Zoom on April 7, 2021, from 5:30 to 7. So winners will be notified before then. I'm very pleased to introduce our judging panel today. The first judge is the PO York Chapter Chair, Annabelle Lee. She is also a K-12 IT security specialist at IBM. We have Helen Deng, the rapid transit sponsor at Metrolinx. We also have Anna Murray, the Proton Exchange Membrane Technology Product Platform Manager at Cummins Inc. Our fourth judge is Marissa Sterling, President of Professional Engineers Ontario, and she is also the Assistant Dean and Director of Diversity, Inclusion, and Professionalism at the University of Toronto's Faculty of Applied Science and Engineering. Last but not least, we have Monal Chowdhury. She is the Technical Manager of Grid Innovation at Electra's Green Energy and Technology Center. So the schedule is that every finalist will have strictly 10 minutes to deliver their presentation. After the presentation, they will have up to about 7 minutes allotted for questions and answers by the judges only to the finalist. In case of technical difficulties, don't worry, just log back into the Zoom link. Should you be cut off due to internet connection issues during your presentation, you will have 5 minutes to log back in, and you will be able to start at where you left off. So if you made 2 minutes out of your 10 minutes presentation, you get disconnected, you come back and you start from those 2 minutes. Judges, again, have declared any conflicts or any potential conflicts of interest for judging these projects, but regardless, they will be participating in the questioning of all finalists. Again, lastly, finalists are expected to stay for the full duration of their category presentations. So I will be giving an indication at the wrap up to allow everyone to exit out of the Zoom conversation. If you have any questions during the session, please reach out to your afternoon host volunteer applicant host, so that is Hannah, VAH Hanny. I cannot be answering any questions during the presentation because my computer is being used as the presenter, and thus I cannot view the chats. If you get disconnected, don't worry. Our volunteer applicant host will fish you back from the waiting room. And if you don't know who to reach out to, you can private Zoom message VZ Reza, and he will point you to the right person. So without further ado, I cannot forget the wonderful volunteer team that we have today to pull this off. It is definitely a team effort, and today we have Reza, we have Huzaifa, Hani, myself, Lisa, and Demilare, who made this entire operation possible. In addition to the people here, we also have additional volunteers that have helped us throughout this awards process to make this year's competition possible. And I would like to give a big thank you to all of them who are very hardworking, committed, and dedicated to volunteering for the awards committee and to making this awards competition successful. So without further ado, I would like to ask the first presenter, so R1, to get ready for their presentation.
Good afternoon, judges. My name is Mike Dang. I'm presenting one of the solutions to climate change, and that is to use SMR. It's an acronym for Small Modular Reactors. Slide 2, please. Now, in this slide, you can see the objective. Our objective for this paper was to give an overview of the need of SMRs in Ontario as a solution to climate change. At the same time, to understand the benefits and challenges of current developments of SMRs. Next slide, please. Now, in the introduction, what we have is the climate change. Everybody knows of the climate change we experience on planet Earth today, but its impact on our transmission lines. We have about 29,000 kilometers of transmission lines at 500, 275, and 230 kV lines. And its impact is tremendous because of global warming. Okay, what it does to our electrical transmission lines is very important and crucial to us all. Next slide, please. Here is the evidence of climate change. From global warming, we experience wildfire, flooding, and drought. Next slide, please. And here its impact on our transmission lines. The temperature will cause the line to sag. And if it sags below a certain or exceed its elastic limit, it will remain sagging. And it will cause flashovers to whatever we find beneath the line. We have winter storms. This is taken in 1999-2000 in Ottawa, where the line crumbles, the tower just went to pieces because of the weight of snow. And then you have gale force wind, the bottom left-hand corner, and the lines went down on the right-hand side, the bottom right-hand side. Next line, please. Here, it gives you a small idea of what happened, especially in the Toronto areas, in the GTA. We have tornadoes in Vaughan in 2009 on August, causing a lot of damages. We have twisters in York region in 2014 with the 17 twisters, etc. These map just to give you an idea that it's not only the whole of Canada, the province of Ontario, but in and around the GTA. Next slide, please. Okay, so what is the solution? We believe SMR will play an important part in solving the problem of climate change. And SMR is an acronym for Small Modular Reactors. Next slide, please. Okay, but before I start going into that, I'd like to go a bit on the basics of the nuclear uranium. See, uranium-235 or 238 is located in the they call it the actinide section of the periodic table. And for uranium, we have a mass of 235 with an atomic number 92. Okay, this means we have 92 protons, 92 electrons, and if you subtract 92 from 235, we have the number of neutrons, which is 143. The same applies to uranium-238. The diagrams at the bottom shows you the locations of the electrons within the respective shells. Next slide, please. And the impact of uranium, excuse me, you've got to understand fission. When you bombard the atom, the uranium atom, with one atom of active neutron, what happened to the uranium? It splits. Okay, generating more uranium. It could be 236, could be 238, could be radium or other types of active nuclear elements. And when it does that, it releases a lot of energies in addition to extra protons, okay, neutrons. Now these neutrons, if you allow it to bombard the next nuclear, the uranium nuclei, it will split up and jets more neutrons, more energy, and more gamma rays. And then the whole process is fission. It creates a chain reaction. This is what we find in a nuclear bomb. So what do? We have to control the process, the chain reaction. Next slide, please. And this is what the nuclear fuel looks like. It comes in pellets, and they are all lined up inside the uranium rod. This is what it looks like in a nuclear reactor. Next slide, please. And inside the reactor, to control, to make sure that the neutrons do not go and bombard and cause a chain reaction in a reactor, we have to have control rods. These control rods are made of boron, cadmium, hafnium, or other elements that absorbs the neutrons to prevent it from reacting. So if you were to allow the control rod to sit inside the reactor right down to the bottom of the reactor, it will absorb the neutrons. You do not bombard the elements, the whole thing will be stagnant, it stays as is. The minute you bombard with a neutron, then the reaction starts. By allowing the control rod to move up and down, you can control the amount of energy generated from the reactor itself. Next slide, please. So we have a lot of research done all over the world to use these small modular reactors. And the one I'm going to address today are the 5 reactors that are being done in different countries, in the US, in Canada, in China, Germany, England, India, etc. Okay, the first one that I'm going to look at will be the water-cooled reactors. Next slide, please. These reactors is water-cooled. It can generate up to 60 megawatts of electricity. It can reach a core temperatures of about 314 degrees C, and it uses enriched fuel, only 5% of it, using uranium dioxide. Okay, so this is one of the SMRs that are being looked into. The next slide, please. We have the high temperature gas reactors. It can generate up to 272 megawatts with a core temperature of 750 degrees C, and it uses helium as a coolant. It uses only 20% of enriched fuel, and it uses what we call TRISO fuel, stand for tristructural isotropic fuel. Okay, this is done by a company in the state under the name of Framatome. Next slide, please. In this new SMR, they use the liquid metal, excuse me, for fast neutron reactor. It can generate up to 100 megawatt of electricity, core temperature 510 degrees C, and using sodium as a coolant. Again, they use only 17% of enriched fuel and using uranium or zirconium alloy. Next slide, please. Here, we use the molten salt. Again, it can reach to a core temperature of 700 degrees C. It regenerates about 190 megawatts using molten salt as a coolant and only 5% of enriched fuel. Next slide, please. And this is the smallest. It's only 5 megawatt. They call it hot pipe cooling reactors. It reached a core temperature of 650 degrees, and it used heat pipe cooling. The fuel used will be about 20% of uranium nitroxide or uranium dioxide. So all these nuclear reactions and the energy released from the uranium is harnessed, use it to boil water, we get steam, and the steam drives the turbines and hence electricity.
Michael,
yes.
You have 30 seconds. You've already hit your 10-minute limit. Please use 30 seconds to wrap up your presentation.
Oh, yeah. Okay, now on page 19, we do a case study. What happens if you were to replace the power that we import from the grid? Can we use it? And if we use that, then OPG would reduce the amount of fuel used to generate power. And the SMR on page 20, here the SMR replacing the grid. If we have the generators going from the SMR, we reduce the power import from the grid from T1 and T2.
Thank you, Michael. That is your time. To be fair to all the other finalists as well, we have to keep everyone's time limit the same. I will now give the floor over to the judges for 7 minutes of questions.
Great, thanks. Thanks very much, Michael. It's Marisa here. Yeah, appreciate your presentation very much. Yeah, so maybe you could just give us a better sense of the connections between the climate change solution and the reactors. So are you thinking that this is a replacement way of energy generation, or just let us know a bit more about what how you were connecting the SMRs as the solution for climate change?
Well, everybody believes that by going for renewables alone will help to combat climate change. No, it will not. Using electric cars will not affect a lot in terms of climate change because we don't have the structure for it. For electric cars, all households are equipped with 100 amps circuit breakers, new homes 200, but you need more than that. You have to bring in new connections, new wire, new cables in order to use electric cars. The idea is we have a lot of old generation at the nuclear station in Darlington and in Pickering. These are getting old. So OPG with the government and with the AECL, they're working on these small reactors. And it occupies only about 5 acres and is relatively safe so that we can use it. If we can use it and have it interconnected within the GTA across northern, eastern, western areas, then we will be less dependent on the gas generators. And this is one way of combating climate change.
So thank you, Michael. I understand that the concept, but here in Ontario, my understanding is that we actually have a lot of baseload generation. I thought you mentioned this would replace the current nuclear facilities, which are already a baseload. We also, of course, have hydro. My understanding is we actually export a lot of energy to other jurisdictions on the Eastern power grid. So how is adding more base load generation capacity the solution as opposed to variable solutions where I know there's challenges with wind and solar, but combined with energy storage, that could be an option too for the grid. So why are you convinced that more base load solution is the right approach?
I came from Hydro One. The nuclear generators, especially from Pickering and from Darlington, they will be retired in 5 to 10 years' time.
Mm-hmm.
What are you going to do with it? You cannot replace those with a large nuclear reactors. This is why the government and OPG, AECL, working behind the scene to replace these. And because they are relatively safe in comparison with the other one, the cost again is only about 1/3 of the large nuclear reactors.
Mm-hmm.
So it's doable.
Okay, so you're suggesting that we need to replace our current baseload with new baseload.
Yes. Yes.
Okay.
And Michael, can you explain a little bit more about the transmission piece? So you were showing us the impact of climate change on transmission lines. What is the new scenario with the SMRs in place?
The transmission lines stays as is. You see, nobody looks into the application of SMRs vis-a-vis the system that we have. We're not going to shut down work in the OPG because OPG now will be spending money to replace the existing nuclear reactors by SMRs. The transmission and distribution structures that we have today will stay as is. And this is why in one of my diagrams that I tried to present on page 20, here, once we replace it, the amount of import that we have on the transmission transformers will be reduced. If you have generation that provide the base load, like Ms. Anna Murray was asking, then the need from the grid will be reduced. Okay, so if everybody have their own nuclear reactors, which is the SMR I'm talking about, then the need to import them will be tremendously reduced. The losses will be reduced, but they are there, the structures is there. In the event of the shutdown of the SMR, the loss of the SMR or whatever, we return back to normal structures. We still have the import from the grid. And if we have a lot of these SMRs connected, then what happened? We will stay connected, will be self-contained by each utility. So once we are dependent on power, and with the amount of power we get cheap electricity, look what happened to the lives and work of everybody. It improves their livelihood, it improves their skill, and the country, the nation, the province prosper.
Thank you, Michael. I have, Marisa, do you still have a follow-up question?
Fine, yeah.
I have a question that, Michael, could you let us know that where are we with this research? Which stage are we at? And is there any collaboration with the government for this research?
The research is that could you believe it? It was Bill Gates who financed this. Okay, he is the one who pushed for the SMRs to come to the surface. People were squashing them because of large nuclear reactors. Today, as we speak, the molten salt reactors are being tested in Ottawa. I forgot the name. It's the white something. Anyway, it's being tested. Okay, because of COVID, it's not being publicized. We cannot go at 100%. Okay, we are trying to get it up and running. We have commercial entities and people interested to finance. Once it becomes viable, it will be in production. And would you believe it? It can be transported on the trucks, a bed truck, to sites and assembled on sites. It's that simple. And everybody is really, really anxious to get it up and running to prove to the public that these SMRs are here to stay. They're easy to manage, easy to assemble, and occupies only 5 acres of land. That includes the reactors as well as the generators and boilers.
Thank you very much, Michael, and thank you, judges. That concludes the Q&A for this presentation. The judges will now go into a separate breakout room for 3 minutes to write down their answers. So Reza, if you can open that up. I would like to ask the next presenter, please, to get ready. So that's the R2 project presenter. Maria, if you could please request remote control.
Yeah, can you hear me?
Yes, I can hear you clearly.
Let me just do that. Okay, here you go. Request, yes. Okay.
Approve. Okay, so please just test out that you are able to advance the size. Okay.
Yeah.
Perfect.
Can you see my mouse?
Yes.
Perfect. Sounds good.
Okay. So the judges will be in their room for still 3 minutes, so
Okay.
2.5 minutes. So, but I will give you a verbal indication of when your presentation is starting once the judges are back.
Okay.
Again, after your presentation is done, I will be, as with the previous presentation, stopping sharing the slides, so so that the judges can see you and every other judges when you are answering the Q&A. And as you again, for you as well as all of the other contestants, make sure you have a device or something that keeps track of time, because we will be cutting off everyone strictly at 10 minutes. And if you go over, then we will give you 30 seconds to wrap up your presentation.
Okay.
Thank you.
Không, chờ anh mới nói dạ tới phần 10. Có what happened? Rồi cũng muốn anh nghe. Cho anh 10 phút.
Michael, you're not muted. Sorry. Please. Thank you. Just checking in on the judges that thanks for your patience, everyone. We're just waiting for the judges to come back and we will proceed with this presentation. Thanks for your patience, Maria. We're just the judges are just finishing up writing down their scores, so
Don't
it'll
worry.
just be a moment.
Don't worry, Sharon.
They're coming back now, which is great.
No.
Okay. Perfect.
Sorry about that, Sharon.
No problem. Okay, so Maria, so I will be counting down 3, 2, 1, go, and I will be starting the 10-minute timer starting when I say go, okay? So now that all the judges are back, please begin your presentation in 3, 2, 1, go.
Okay, so hello everyone. My name is Maria Jacom. I'm from Humber College, and I'm here to present the result of the numerical modeling of fluid migration in a sanitary landfill by combining geophysical and gas emission data. I want to acknowledge the my research partner, Professor Cristina Amon. She's from the University of Toronto. And here you find a list of collaborators. Pamela Petraskovich and Chris Drielsma are our industry partners from DEI Geoscience. The main goal of this project was to find a better way to monitor landfills. It is known that landfill is the main source of groundwater pollution. And also landfill gas, in particular methane gas, is one of the main contributions to global warming and climate change. Traditionally, conventional method of monitoring landfill is by drilling a series of monitoring wells in all around the landfill and collecting water quality parameters or water quality information 3 or 4 times a year. This method is time-consuming and very costly. So we're proposing here a better alternative, which is a geoelectrical characterization of the groundwater contamination, and also try to find a synergy between methane superficial emissions and leachate accumulation. Leachate accumulation is just the accumulation of contaminated fluids produced by the landfill. So it is known and is being recognized by the United Nations, by provincial and federal jurisdiction, and also by the Assembly of First Nations that drinking water or safe drinking water is a main priority, especially for rural communities and urban communities that depend on groundwater as the main source of drinking water. So the advantage of the method we're proposing here is that it's non-invasive, is low-cost methodology that will delineate accurately the contaminated fluids and also the gas plume migration. Also, the field data analysis is available immediately after the field work, which will basically make this a good technique because they will help to make responses of the problem to be analyzed, fast responses. The quality of the data and the graphical and detailed information of the data will be used for prevention, mitigation, or remediation of contaminated sites. The methodology of the project that we did was, first we collected in here a series of geoelectrical tomograph of the subsoil in the landfill. Simultaneously, we collected about 140 methane readings or concentration of methane readings on the surface. And then using machine learning, we created a model that produced the synergy between methane readings and geoelectrical information. There are only few reported studies in Canada that apply geophysical prospecting to characterize landfills. The only one that produced a comprehensive geoelectrical and methane modeling of the landfill is the one that we created or we produced last year, and we published the result of this information in a peer-reviewed journal last year in 2020. And unlike earliest investigation, methane concentrations are predicted by employing geophysical proxies of leachate accumulation. The landfill is located in North Toronto, Northeast Toronto, and here is the geomorphological features of the landfill. And in this map in here, you can see the topographic map showing the location of the geoelectrical cross sections. 3 of them are located in the same direction of the groundwater, and 1 is located parallel to the landfill. These data, this geoelectrical cross-section are about 300 meters in length, and we collected in less than a week more than 5,500 readings of geoelectrical information from the site. Also, in this well, our industry partner collected geophysical well log information that was used to control our geoelectrical modeling. The landfill is located in an shallow, unconfined aquifer, and there is a confined aquifer that is divided by an aqueduct or a layer of clay and silt. Here is the result of the geoelectrical cross sections, and as you can see here, we are showing different scales or different resistivity values of the subsoil. So red and oranges are low resistivity values, and they are associated with saturated soil with salty water or contaminated water. Whereas the blues and purples and greens are associated with medium to high resistivity values, and they are associated with non-saturated soil or soil that is saturated with fresh water. And as you can see, this is the location of the landfill, and this is a contaminated plume that is migrated towards the southeast. And there is another contaminated plume that is migrating towards the northwest, okay? So this plume in here was not previously observed by traditionally monitoring on the landfill, and as you can see, is present in all the different geoelectrical cross-section or tomograph. The final result of this project was a model that basically was done using machine learning, in where we use high conductivity values as proxies of contaminated area or contaminated land leachate, or what we call the waste stabilization zone. And as you can see here, there is a good match between the observed methane readings, which are the crosses, and the predicted methane information or concentrations. As a conclusion of these models in here, we're showing only 2 examples of the models. We can say that methane can be used as a first, methane readings on the surface can be used as a first approximation of the location of the contaminated fluids underground. Here is just a 3D extrapolation of the 4 geoelectrical tomograph. And as you can see, the quality of information is quite good. So we can generate a 3D cube, and we can see and map exactly the location of the contaminated plume. And also in this particular case, we also saw a new plume that was not previously detected by monitoring or conventional monitoring wells. Here I'm showing you just a graphic abstract of the project. And you see when we get a biopsy sample on a human tissue, we need to know exactly where the location of that biopsy place is going to be. So we need to have at least a CT scan of the area. Similarly, if we want to drill a monitoring well in the ground, it will be a good idea to have a very clear image of the subsurface or the landfill site. That is very, very important because it will help us to drill efficiently the places where the monitoring well should be. And also it will help us to design a remediation campaign that is going to be more accurate. Cost studies shows that conventional monitoring per well costs about 3 times more than a geoelectrical methane survey of a line of about 300 meters. Only in the GTA, there are more than 160 closed landfills, and the monitoring cost of these landfills throughout the life of the landfill is about 120 million after they close. So that is actually assumed by the taxpayer, that cost. In particular, in the York region, and there is a small landfill in Marham that costs about $150,000 to monitor it per year. These figures increases annually and become very important, and is a financial burden on taxpayers. Geophysics technologies has been used, or the geophysical method has been used traditionally by the mining, oil, and gas industries. However, civil and environmental engineers are now actually getting these techniques in order to monitor the landfill. The main challenge that we found is resistant to change, or resistant to change the paradigms. As a conclusion, I can say that this is a method provided a comprehensive and continuous view of the landfill, which is an advantage of the fragmented picture of conventional monitoring, improved landfill characterization and monitoring techniques as a significant lower cost and reduced time, which is translated into saving for the taxpayers, helps to make rapid decisions about prevention, mitigation, and remediation of contaminated sites, and also can be used to plan strategically the groundwater, contribute to developing strategic environmental plans that respond to the growing needs of provincial and municipal agendas in terms of groundwater contamination. Here, I just want to show you a picture of the final landfill, and that's it. Thank you for your time.
Thank you, Maria. The judges may begin asking their questions, starting now, please.
Maria, thank you very much for your presentation.
Thank you.
Can you just give a bit more of an overview in terms of geoelectrical surveying? So where else is it used today, and where else could it be used? I think you were starting to say that at the end.
Yeah, so basically it's used, it's been used traditionally in the mining industry to detect accumulation of mineral resources, especially because what geoelectrical information does is that it gives you an image of the subsoil where different electrical conductivities and resistivity properties of the soil or rocks or minerals are. So we know that, for instance, metallic mineral accumulations are giving you high conductivity values. So that's what we're looking for in mining exploration. In Europe, resistivity resistivity information has been used for some environmental studies as well, whereas in Canada, it's starting to be in use right now. So we are just, getting into that market. And it can be used not only to determine, leachate accumulation in a landfill, but also can be used to determine contamination or metallic contamination associated, for instance, for mining tailing ponds. That could be another use of resistivity and conductivity values as well. So, yeah.
Great. And just another follow-up is, can you speak a little bit about any potential partnerships or are there any industry connections to some of the research happening right now or plans for?
Yeah, so this is this project was funded by NSERC. So we finished and we partner with Simcoe County. So they wanted to work with a landfill in Simcoe County and trying to see and understand more or less how the the migration of the fluids were. Now what we're doing is that we are in conversation with First Nation communities because this is very applicable for rural communities, especially vulnerable rural communities like First Nations that relied on groundwater for the main source of the drinking water. So in order to protect their aquifer, we need to do this kind of studies, not only to be sure that, the aquifers is free of contamination, but also if there is any problem, we would like to know in advance where the problem is going to be, just to design a good remediation, campaign. So yes, we're in the process of working and writing and talking to First Nation communities as well. And also, I'm thinking in the future, maybe, even mining industries will be interested in adopting this technology to see if there is any leaking or spill in their tailing ponds as well. And they also, another advantage of this is that it's a non-invasive technology. And we are also in our second phase of this project. We want to introduce the use of drones to be able to fly a drone with an electromagnetic sensor that will be able to collect data even though without even putting a foot on the site. That is very important, especially when we are dealing with contaminated sites and we want to protect our crew. Yeah.
Thank you very much.
Yeah, thank you.
We still have 3 more minutes for questions.
You had said you had published this in a peer-reviewed journal. Have others done studies of a similar nature for this application specifically?
In Canada, there are 5 researchers on using geoelectrical monitoring or geoelectrical prospecting to understand landfills. This is and these 5 previous work are, I think, 2 master thesis and I think 3 Congress, abstracts. From what I know, in Europe, there is a lot of information. Yes, so Europe, they have more publication regarding to these kind of results. And but yeah, so the only publication in Canada that I know of that uses numerical modeling to find the synergy between methane and geoelectrical information is the one that we produce. There is some research that has been done and they determined that there might be a synergy or a relationship between methane and leachate production. But the first time we quantify that using machine learning was in this program.
Okay, because that was going to be my question, is if there had been other studies to validate the correlation results and confirm if there's a causation there as well.
Yeah, so there is, but this is the first time we quantify that. Yeah.
Okay.
Thank you, judges. I will be now, and thank you, Maria, for your presentation. The judges will now be moving to their breakout rooms for their writing down of their scores. I would like to ask now for the R3 project, which is HydraTek, to please get ready for their presentation. Thank you. Okay. Hi, Fabian.
Fabian, yes.
Fabian, sorry. Fabian, would you please request a remote control?
Where did we do that the other day?
View options, green bar on the top.
Yeah, oh, there it is.
Yes, okay. I am approving right now. Just make sure you can flip through your deck.
Yep, looks like we're in control.
Okay, sounds good. So we still have about 2 minutes before the judges come back, but I will give you a verbal indication and a countdown as I do with the other contestants to start, finalists to start your presentation.
Sounds good. It's been a long day for you.
It is for the team, and I appreciate every finalist's patience in waiting. I understand that we are running a bit late, so really appreciate everyone for applying for the award, being here as a finalist, and being with us. We're very grateful for everyone here.
Yeah, we're grateful for your work. You're doing all the heavy lifting there.
It's not just me. It's also all the team. So Reza, Huzaifa, Lisa, Hani, Demilare, everyone. They've been here with me. It's definitely something that I cannot do on my own. It's a team effort for sure.
Well, good work.
Thank
you.
You.
Have a nice relaxing evening after this.
Definitely. Oh, it seems like the judges are coming back. We'll be all here in 4 seconds. Perfect. Well, thank you, judges. So all the judges are actually back, so I'll give you a countdown. So please start your 10-minute presentation in 3, 2, 1, go.
Good afternoon, and thank you for your attention. We're honored to make this presentation to you, and hope you'll find it interesting. In a nutshell, this project is about reducing leakage in the large water distribution systems that lie beneath our cities. Here are some photos, one of leaky water main, what it looks like, as well as the inside of a typical water pumping station. This happens to be in York Region. In short, reducing leakage also reduces the considerable amount of pumping energy that is used to move water from where it is, places like Lake Ontario, to where it is needed, overcoming both distance and height, as well as to pressurize it for use in our homes and businesses. Both the reduction of leakage of water as well as the reduction of energy consumption reduces operating costs for municipalities. And to that end, this project involved the development and deployment of a mobile testing unit pictured here. Its function is to obtain key measurements that can diagnose whether a test site is performing well or poorly from a leakage point of view. This image shows where the field tests were conducted across the province. In addition to the field testing, these municipalities also received training as well as debriefing workshops. This plot shows what several days of water flowing into a typical test area would look like. One of the key underlying technical principles is that the minimum night flow in our water systems, as identified by the horizontal orange line in this plot, is both predictable and reliable. A high minimum night flow is indicative of excessive leakage. Quick word about the key players involved. Bradley Jenks was the principal researcher for this project, which formed the cornerstone of his Master of Applied Science and degree in Civil Engineering from the University of Toronto under the academic supervision of Dr. Brian Carney. HydraTek and Associates was the project's industrial partner, and I was the responsible engineer on the project. And the whole project was made possible through the financial support of the Independent Electricity System Operator of Ontario, IESO, through its Grid Innovation Fund. And that was in recognition of the amount of energy needed for water supply to our cities and towns. Additional funding was supplied by the National Research Council's Industrial Research Assistance Program, the Natural Sciences and Engineering Research Council, and the MITEX Acceleration Program. And quite importantly, the support from the participating municipalities in relation to the provision of test sites, as well as the provision of engineering and operations staff time was critical for the success of this project. Here's a snapshot of some of the key results. This plot here shows the minimum night flows for each of the test sites that were looked at. As you can see, there is a large cluster that lie roughly along a linear trend line, which can be classified as generally healthy test sites, and from which we can establish an industry benchmark. There are also some very clear outliers. These are the ones that obviously we're most concerned about. This metric alone can diagnose whether test sites have excessive leakage, as well as roughly the amount of that leakage. Additionally, the mobile unit is equipped with a pressure reducing valve that is used to directly test how changes in pressure affect flow and leakage characteristics in the system. This plot on the right shows that the cycling back and forth between normal and reduced pressures has an effect on flow and in turn leakage characteristics. The wider the gap in the flow curves, the more pressure dependence there is, which provides valuable information on the nature of leakage and whether pressure management may be an option. This is the first time that any such benchmarking has been undertaken in Canada as well as North America, for that matter. And that's important because the design of our systems is quite a bit different from other parts of the world. So here we see the true proof of concept for this research project, which was provided by one of the test sites whose initial results was represented by one of those outliers. The municipality used those findings and focused its efforts to go and find and repair a significant leak. And after retesting the site, its performance matched that of its healthier peers. This was quite an exciting outcome, which resulted in savings of a staggering 140,000 cubic meters a year. That's 140 million liters a year, or about the equivalent of 75 of those elevated tanks you see on the screen. That's the amount of volume per year that was being lost through that particular leak. It amounts to 102 megawatt hours a year, or 5 tons of carbon dioxide if you're looking at greenhouse gases, or enough to power 11 of my homes in a given year. Quite dramatically, the financial savings is really where the attention is, and on this particular slide. The annual savings here is $426,000 a year, the equivalent present value of which was well over $4 million, so rather healthy. And that was from a single leak. In terms of innovation, technical merit, and distinction, key points I want to make include the mobile unit is the only one of its kind in the world, and that the testing unit and the technologies integrated within it result in highly accurate results that can be obtained at a much lower cost than currently available alternatives. By virtue of the mobility of the unit, it is also faster to implement than permanent options. That is, it is better, faster, and cheaper than the alternatives. In effect, the mobile unit is equivalent to what can be accomplished by an underground chamber that would otherwise cost several hundreds of thousands of dollars. As well, the research project was recently referenced in 2 presentations by US practitioners at the IWA, that is the International Water Association's Water Loss Conference that was held virtually in China this past November. And here are the slides from those presentations, which have independently recognized the contributions that this project has made to the industry so far. In terms of environmental and social sustainability, this quote from Dr. Brian Carney at the University of Toronto in regards to the water energy nexus nicely describes matters. If you are thinking about big challenges and big threats, and those topics that are likely to dominate humanity over the century, you might want to think of water and energy. As well, the water energy linkage that this project addresses is promoted in the Environmental Commission of Ontario's 2017 report titled Every Drop Counts. This report is aimed at promoting energy conservation in municipal water systems, noting that municipal water systems could save water, municipal systems could save water, energy, and money by just reducing leaks. And this project has proven the degree of savings attainable for all 3 of those dimensions. Onto commercial viability. This project has proven the value of the mobile testing unit as a diagnostic tool for identifying areas with significant leakage. We have 2 new test sites already contracted outside of the research project, largely as a result of the big win that was discussed earlier. And 2 municipalities have already indicated that they will start programming for this sort of testing as part of their annual work programs. So those are all great things for outcomes from this project. Apart from that, the mobile unit can also be used for other purposes, given its ability to measure flows and control pressures. Things like building meter verification or the commissioning or acceptance testing of newly installed infrastructure system components are examples, but others would exist as well. In terms of impacts, this pilot project and the big win that was discussed earlier was featured in York Region's 2020 Long-Term Water Conservation Strategy Annual Report. This is important because York Region has the highest cost of water in Ontario, and so any leakage reduction will have the largest financial benefit. The high cost of water in York Region is due to its purchasing water from Toronto and Peel. Also, the more densely populated areas of Southern Peel have the highest embedded energy in water by virtue of the distance and height from Lake Ontario that the water has to move. And so, again, reducing leakage has the highest impact on reducing the energy that has to go into that. And of course, now we have benchmarks that are relevant in the Canadian context. And so all municipalities will have access to this publicly available information and use that for their benefit. So with that, I'd like to thank you for your attention. Appreciate that a lot of ground has been covered in a short time during this presentation. I'd be happy to answer any questions at this time.
Thank you very much. I will now turn the floor over to the judges to ask any questions for the 7 minutes will elapse starting now.
Hi there, it's Marisa speaking.
Hello.
Fabian, great, wonderful presentation, very concise. Can you speak a little bit around like reliability and any other aspects of like further improvements that you see for the opportunities in the process in the mobile unit today? Just curious.
Yeah, well, that's a good question. For those that aren't familiar with municipal systems, there's a dearth of sensory equipment in our systems. We typically find them at treatment plants and pumping stations, but not within our distribution systems, which is, it's not that's not, there are no parallels with the power industry, for instance, where there's a lot more monitoring going on. And so, applying these sorts of techniques with additional information would be helpful. Now, there's smart metering is the next logical step to be able to understand how things are moving. There's a very few municipalities in Ontario that have moved to smart metering so far. But when we start integrating that information with the information that we collect through this sort of testing and implementing permanent versions of the system, this is a diagnostic tool. Once the diagnostic tool tells us we need to put in a permanent system, then the big money can be spent. And then integrating that with the smart metering, then you can have real-time information and use AI or machine learning to understand patterns in consumption behavior and leakage behavior. And those things will be able to provide red flags or early warnings of any issues as they come up. So it's still early days in the municipalities world in terms of developing these systems, but wins like this where we had 3 sites out of 19 or 20 there that have certainly had leakage and have motivated the municipalities to go and look for the leakage in those specific areas. And so the benefits are obviously tangible and immediate and meaningful, particularly in your region where the water is expensive.
Mm-hmm. And would there be any considerations in order to expand out to other municipalities? Like you said, there were 2 more that have interest. Is it very much kind of like plug and play in terms of being able to expand out, or will there be some other considerations or challenges in order to have a more broader
I think,
chance?
yeah, that's a good question. So there's municipal, we had 8 municipalities participated in this project. So, we went as far north as Sudbury, as far east as Ottawa, and cluster in and around the GTA, including Toronto. So it's proven that we're able to use this in all those systems, and it was designed with North American systems in mind. The biggest difference in systems is whether a system has chambers where the valves are located, or whether it does not have chambers. Some of our municipalities just have direct buried valves, in which case we can't plug the hoses and piping into those chambers. In those cases, we connect to hydrants. So it's a slightly different setup, but we did have 5 test sites that included hydrant-to-hydrant connections that we deployed in the fall of last year. So we've got North America covered, and we've got the word out there. So it's and we have 1 truck. So in terms of market size versus we've got the supply-demand balance working in our favor at the moment.
Yeah, great, thank you.
Yeah, what's the typical setup time to get it connected, and then I guess demobilized at any given site?
So good question, because a lot of thought has to go into it before you get to the site, and some preliminary reconnaissance work, and just preparing the site for it. So that work may involve tapping the valves, or just checking whether the valves work. It's incredible how many valves do not work in our systems. We often use the Rod Burgundy line of 60% of the time it works every time for our valves, and that's typically what it is. So the prep work is critical. But once that's done, to set up, it takes maybe half an hour to an hour to get set up and running, and then we measure flow through the night, and it takes maybe just about the same time or less to dismantle things in the morning. It's obviously not as much fun for some of the folks doing the testing, because the testing can only happen overnight.
Mm-hmm.
And we don't do that testing during irrigation season, for instance, because the irrigation will mess up the results. And so Bradley's on the line here, and kudos to him for spending every single night of testing out there during blustery conditions. Well, I think one of the photos had a bunch of snow in it.
Yeah. Well, one other question I had, you said there was quite it looked like there was a very direct correlation between flow and nighttime usage, but would that not vary in high industrial application areas where they could have a 24/7 operation using water?
That's right. So this project was restricted to commercial, to residential uses for that very reason. You would have to go to a site-specific approach for those industrial areas. So it's good. Can't cover everything in the 10 minutes, but yeah, very good observation.
Okay. So that correlation was for residential use areas. Then.
That's right.
Very cool.
Thank you, judges. That is our time for the questions.